Welcome to discussion 17. In today's discussion, we'll be focusing on section 3.9 on related rates. And in this video, we will do a ladder example. So this is problem number 3 from worksheet 8, which says that a 6-foot ladder is leaning against a wall. If the bottom of the ladder moves away from the wall at a speed of 3 feet per second, how fast is the top of the ladder falling towards the ground when the bottom of the ladder is 3 feet away from the wall? So first, give yourself 4 minutes to try this on your own. 4, 3, 2, 1, pause it and try this for 4 minutes on your own first. That's really important, especially with these related rates questions, which can be more challenging, to really give yourself a chance to try it first to assess how well can I do something like this on my own. All right, let's talk about it together. So remember, to get us started, the first thing that we should do is draw a picture. So let's draw a picture. So in the picture, we can draw a wall, and we could have the ground. And then we have this ladder that's leaning against the wall. Okay, so I'm gonna make this slanted line be the ladder, and the problem tells me that the ladder is 6 feet long. Okay, and I'm gonna have a right angle here. Okay, so I got my initial picture, and then what I do is I assign variables. We assign variables to quantities of interest. So quantities that we care about that are changing. Okay, so there are two lengths here that we care about. One is this horizontal distance from the wall to the foot of the ladder. So this point here is the foot of the ladder, and the vertical distance from the ground up to the top of the ladder. And I care about those distances because the problem tells me something about the bottom of the ladder and how quickly that's moving away from the wall. So that relates to this horizontal distance. And it's asking me something about how fast is the top of the ladder moving, and that relates to this vertical distance. Okay, so our next step is we write down the rates that we know and the rate that we want to find. Okay, so the problem tells me the rate at which the bottom of the ladder is moving. So that's going to involve dx dt. And it tells me that's moving at a speed of 3 feet per second. So I'll put a 3 there. And because it tells me that the bottom is moving away from the wall, this point is moving this way, which means x is increasing. And if x is increasing, my dx dt should be positive. So this is positive since x is increasing. Okay, and I want to find how fast the top of the ladder is falling. So that is related to dy dt. All right, so we are ready now to set up an equation. So now we need an equation that relates the variables that we have. So because I have this right triangle, I'm going to do Pythagorean Theorem. X squared plus y squared equals 6 squared plus y squared equals 6 squared. So the problem also tells me specifically, one of these lengths at the instant that it's talking about. It asks me how fast is the top of the ladder falling when the bottom of the ladder is 3 feet away from the wall. So I'm trying to find this dy dt when x is 3. So it might be tempting to say, oh, x is 3. Can't I just plug that in for the x right now? But as we mentioned in lecture, we don't want to plug in values that are changing until after differentiating. Until after differentiating. Okay, so let me put a bubble around that. All right, so let's take the derivative now. So we will take ddt of both sides. All right, so we're going to take ddt of both sides. We'll have ddt of x squared plus y squared equals ddt of 6 squared is 36. Okay, so now I have to differentiate implicitly because the t is different from the variables that I see here. So first I take the derivative of x squared kind of as I normally would, which is 2x. But then I have to do chain rule and multiply by the derivative of x, which is dx dt. So same thing for the y. I'll get 2y times the derivative of y, which is dy dt. And the derivative of 36 is 0, because that's a constant. Once I've taken the derivative, now we can plug in what we know. Now we can plug in what we know and then solve for what we're after. So let's see, we'll have 2 times x, and I know that we care about the specific situation where the x is 3, so let's plug that in. Let me also just start to draw a picture of that specific situation. So I'm going to have my right triangle, and the hypotenuse is 6, and we are looking at the case when x is 3, and I'll call this y. Okay, so times dx dt, and let's see, the problem told me dx dt was 3, and then we'll get plus 2 times y, and then we want to know what dy dt is, so that is going to remain as a dy dt equals 0. Okay, but I need to figure out what y is, and now let's use this right triangle with the x value plugged in to get y. So by Pythagorean Theorem, 3 squared plus y squared equals 6 squared. If we rearrange this, we get y squared equals 27, and then square rooting that, we would get y equals plus or minus root 27. That's going to simplify to y equals 3 square root 3. I don't need plus or minus because y is a length. So we don't need a plus or minus since our y value is a length. All right, so let's plug that in. So our y value is 3 root 3. Okay, so 2 times 3 times 3, that is 18. And then the 2 times the 3 here is giving me 6 root 3 dy dt equals 0. So let's isolate, let's subtract 18. 6 root 3 dy dt equals negative 18. And then dividing, we get dy dt equals negative 18 over 6 root 3. I could cancel a little bit to be left with negative 6 on the top and just root 3 on the bottom. And the units, so the units of y, of the lengths in this problem were feet, and the units of t on the bottom of time were seconds in this question. Okay, so that's the rate at which y is changing. It's changing at negative 6 over root 3 feet per second. The fact that we got a negative value here tells me that y is decreasing. And conceptually that makes sense, because if the bottom of the ladder is moving out away from the ball, we'd expect the top of the ladder to move down. Okay, so the final thing is, remember, the question asked me how fast is the top of the ladder falling towards the ground? That means we're sort of considering the direction towards the ground as the positive direction. So if my top of the ladder is moving towards the ground, which it is, my answer, my speed here, should be a positive number. Okay, so we need to adjust the value that we got to answer the question. So I'll put an implication arrow and say, okay, the ladder is falling towards the ground at 6 over root 3, positive 6 over root 3 feet per second. And I said this before, which is why I just quickly wrote it here. This is positive because the question implied that we want the direction towards the ground to be the positive direction. And that's the direction that the top of the ladder was moving. It was moving towards the ground.